Hello everybody. Today we are going to study two important examples from the problem set of the chapter Arithmetic Progression for the class 10. So the example is like this. Sum of first p terms of an arithmetic progression is equal to the sum of first q terms. That means we have given a condition is that sum of first p term is denoted by sp. This is exactly equal to sum of first q terms of an arithmetic progression. This is provided to us, this is given to us. Now with the help of this we have to show that sum of first p plus q term is 0. Now we will see how to prove these things. Now we know that for an arithmetic progression we know that for an AP, for an arithmetic progression, Sn, that means sum of first n term is given by n by 2 into bracket 2a plus n minus 1 into d bracket close is the formula of first n terms of an arithmetic progression. Now by using this formula we can have the formula for SP as well as SQ, that is by replacing n by p and q respectively. So one can easily write SP, just replace n by p upon 2 into bracket 2a plus, this n is now replaced by p minus 1 into d bracket close. Similarly we can have the formula for SQ which is equal to q divided by 2 into bracket 2a plus, here again n is replaced by q, now q minus 1 bracket close into d and the final bracket close. So these are the two formulas that we are required. Now but we have given one condition, just we had seen initially. That condition is sum of first p terms is equal to sum of first q term, that is SP is equal to SQ. This is provided to us, this is given. So now with the help of using this information we can have the replacement for SP and SQ by the above formulas. So one can replace SP by p upon 2 into bracket 2a plus p minus 1 into d. This is equal to q divided by 2 into bracket 2a plus q minus 1 into d bracket close. Now these two equalities, or this we are getting an equality. Now by using these two equalities we can proceed now further. Now further we are having a very simple kind of calculation part. Now both 2's in a denominator, from the both side we can cancel each other. So now we are left p and q outside the brackets. So our target is to just multiply by p in inner side as well as from q in the inner side of the bracket. So this multiplication will gives us what will gives us p into 2a is nothing but 2ap plus p is now multiplied by the other bracket, that is p minus 1, p into bracket p minus 1. This is further equal to, if I multiply q inside we will get 2aq plus q into bracket q minus 1 into d. So just multiplication of the bracket. Now we will move this total two terms to the other direction or in the other side of the equality. So this will convert all the signs of the other side. So now I will making sure that I am placing the same terms sequentially, that is 2ap यानंतर आपण रिप्लेस करूया 2aq that will become minus 2aq. After that we are having the remaining two terms plus p in a bracket p minus 1 minus q into bracket q minus 1 into d. This is equal to 0. So now we are getting this equation. Now again a simple part of calculation is there. If I consider these two terms and final two terms, we have to take a common. So from first two terms we can have very simply what we can take a common to be 2a can be taken common, so in bracket there remains only p minus q, whereas from the other two terms we can have d as a common, as d in a both side is there, so we can take a common. So in bracket there left only p in a bracket p minus 1 minus q in a bracket q minus 1 bracket close. So now next 3 or 4 steps will be the calculation belongings to this bracket. पुढच्या 3-4 स्टेप्स या ब्रॅकेट्स मध्येच कॅल्क्युलेशन पार्ट होणार आहे. सो सी केअरफुली व्हॉट आय एम डुईंग ओव्हर हिअर. सो नाव दिस 2a in a bracket p minus q remains as it is plus into bracket I will write completely multiplied by d equal to 0. So now our target is to just multiply by p inside and q inside, so that will allows us this change. P into p will gives us p square minus p, and by multiplying by minus q we will get minus q square, minus minus become plus q. Okay, so now further we can have this 2a plus p minus q remains as it is, plus again we are having a very similar kind of assumption. We are having the bracket, and now our job is to perform the operations inside the bracket. Now I will just rearrange the terms by p square minus q square sequentially. After that minus p plus q, minus p plus q. So now again we are having other terms to be as it is, 2a in a bracket p minus q, plus again we are having a bracket into d equal to 0. Now the calculation part from the inside, we are having formula or expansion for p square minus q square by using a square minus b square, which allows us to do addition of both in a first bracket p plus q and p minus q in another bracket. And now I will take minus common from the other two terms. If I take minus common, that allows you to make p minus q as the other bracket. So now this is very simple. Now if I consider the second this bracket, we will observe that this bracket p minus q and p minus q is common to the both the terms, so we can have again a common for the pair with d. So 2a in a bracket p minus q plus one can has already d is common, so there is another bracket as a common p minus q equal to 0. So there only left inside the bracket is p plus q minus this complete bracket is outside, so there is only 1. So now if I observe these two terms, that means this is the first one and this is the another separated by addition symbol, we can observe that we can have this bracket p minus q as well as p minus q we can take outside, complete outside, so that will gives us. So if I take p minus q outside the bracket, this is equal to 0. So what remains from these two terms? from first term there is 2a, and from another term p plus q minus 1, and here is only d. Okay, so now we are getting two brackets whose multiplication is 0. This is the first one and this is the another term. Two brackets or two terms whose multiplication is 0. This implies that, what this implies, either the first term 2a plus p plus q minus 1 d, this is equal to 0, or one can write p minus q, this is equal to 0. But from the given information we have provided is that, but in example we have given p is different from q. As p and q are different, their subtraction must not be equal to 0. Means we can state p minus q should not be equal to 0. So what this implies? This implies that the other possibility, that is 2a plus p plus q minus 1 into d, this must be equal to 0. So we will suppose this as the equation number first. That is, by given, by we are come to the point from the given information that SP is exactly equal with SQ. By using this condition and by simple part of calculation, we will come to the equation number first. Now we will move towards what we are required. That means we have to find, what we have to find? We have to find sum of first p plus q terms, that we have to find this term. Now to find this term we will replace n by p plus q in that formula of Sn. So one can has S p plus q, just replace n by p plus q, we will get p plus q upon 2, n by 2, there is a replacement for n is p plus q. So 2a remains as it is, plus into bracket n minus 1 means p plus q minus 1 into d, bracket close. So now if I observe this equation number 1, in equation number 1 we are getting 2a plus p plus q minus 1 into d, its value to be 0, and in front of us there is a bracket, there is a exact same term, so one can replace this inside brackets value, that means p plus q upon 2 multiplied by this total bracket, and its value becomes 0 from equation 1. From equation 1 वरून याची व्हॅल्यू आपण 0 बनवू शकतो. So we are getting finally sum of first p plus q term is equal to 0, and that is what we required over here, that is to prove s p plus q. So this is very simple kind of example, but very important as far as concerned of the chapter probability and its problem set, example number 12. In a very similar manner we can easily prove the 13th example. On the parallel line we can have the proof. So this is for the day. Thank you. Thanks for watching.